Hello, hello. How is everyone doing? Welcome to the stream. Welcome. So, we're back for more Voyager Dev. Let me check my audio really quick. Voyager Dev. Okay. Everything seems to be all good. So, great. So yeah, it's been a little while. My last stream was on Wednesday, last week. So I didn't stream on Friday. That's because I was doing some stuff. And yeah, so yeah, that's why I'm streaming today. But yeah, basically, what's been happening is I basically was very busy, and that's why I couldn't basically stream. But I was working on the game, yeah, there were a couple days, I would say, throughout the weekend that I was working on the game. Even though I didn't stream, I was doing some work here, and I was also reading and reading some stuff about the state machines and hierarchical state machines and behavior trees and that kind of thing. Of course, I didn't actually study properly, whatever, but I have been reading, and I have a bit of a clearer mind right now of how they actually are being used in games. So I already had an idea of that, but when it comes to games that have complex character systems, yeah, it's not easy to, it's not very intuitive actually. So yeah, and the thing is, my game kind of has a complex character system because I want the player to have the ability of to be able to do a lot of actions. I not only want you, the player, to be able to run and jump and do some platforming and just shoot and that's it. I basically want to do multiple actions. As you can see in the game, as you may know, in my game, you can, for example, climb ledges. So for example, if you jump into any kind of ledge or wall that's too high, you can grab into the ledge and climb it. So that's something, one of the examples of the things I want you to be able to do in the game. I want some advanced platforming mechanics, not only just running and jumping. So yeah, I also maybe want to experiment with some maybe wall jumping or wall climbing, and I want to also add other layers of complexity. For example, I want you to be able to explore underwater, swim and do stuff while swimming. So yeah, it's not easy, of course, and it's kind of a big scope to have. But yeah, I just want to do that because I just want to learn all that thing, and that's how I want my game to be. I want to my game to have that many layers of complexity and mechanics and everything. And of course, I always say yeah, I have to keep it simple, of course. Always try to keep it simple, to not complicate and make my life harder, just for the sake of having lots of mechanics and making the game really complex. That's not my goal. My goal is not to make the game like unnecessarily complex. I just want to have like fun mechanics that I feel that are fun, and I want my game to not be simple. Like I really like games that have like some kind of I don't know, like deepness in their mechanic aspects, and yeah. So yeah, basically that's the main thing why I'm trying to do this, like to make the game the way I'm trying to make it. And yeah, so also I will try to not talk like a lot because okay, first of all, let me just restart StreamerBot. This is really annoying. It's like I have to do this pretty much every stream. It's really dumb because you can see there it says again 0 viewers, even though it should say 1. Okay, is it working now? Okay, now it is. I can open up this and I can do this again and this. Okay, we're back to normal. So basically, yeah, this stream is going to be short. I think I'm going to be here for a little while. I just wanted to yeah, to at least go through the things about the current like behavior and state system for the character, which is not only for the character, for the astronaut, but also for every entity in the game. And I just want to go through what the thing is, like lay out the actual components that that have to do with the state machine system and everything. So that's kind of what I tried to do in the previous stream. And yeah, in the previous stream I was really tired. I'm always like tired because I always say, I finish working, like finish my work day at my current main job, and then I start streaming. So my brain is kind of tired at this point because it's, you know, 8 hours of programming into more programming. Is not great, but yeah, it is what it is. So but yeah, in the previous stream I was really tired, and I feel like I hit a wall really hard with the system, and I, you know, like I needed to start like doing some research and reading more about things and learning things, and I didn't want to do it on stream because I feel like that's a bit boring, because I don't know, this is just my thought, and maybe people find that interesting or not boring at the very least, but I feel like I've set myself in a position where when I stream I try to do things that I know to the point where I can explain it while I'm doing it, and not often I don't really feel comfortable working on or like working on something that I don't really know and I'm trying to learn while I work on that. I'm always learning, of course, but yeah, I don't know. It's been 15 minutes, so I will try to not extend too much the talk. And yeah, just as you can see here in the current, we have the refactor behavior states. So I have this flowchart thing where I try to do this, but really it's like, I don't know, I will just start like actually writing things here. So I would just create a frame here, Okay, I will call it entity behavior state machine plus VT. So okay, so let's make this. I will try to start explaining the actual thing about this. So what's this? So the entity behavior is that's the name I gave it. But in essence, this is basically a state machine. Okay, so let me just show you here again, because I already shown this, but I will show it again just for the purpose of like having everything in the same video and in the same context. But you can see the astronaut. This is the prefab. This is the entire object. Okay, so here I have the sprite. If you want to like know more and go more in context, you can see, like, you can watch the previous stream, which is number 73. I just realized we're in stream number 74, in the Voyager journey stream number 74, which is, well, as you can see, like down here, my number is 747, but yeah, just a funny little thing. So here I have the sprite, I have the systems. I went through and explained each one of these things in the previous stream. So if you want to know more about this, you can go there, or you can come here into the live stream on Twitch and I can explain it if you ask about something. But basically, one of the systems is this one called behavior, which is basically a state machine. This script that's called entity behavior is in essence a state machine. I just call it entity behavior to give it a different name, and in a more specific way, because I have a state machine that I use for other things like UI and everything, which is a basic, like the most basic version of state machine. But then I have this entity behavior script which inherits from the state machine class and has a couple other components and fields that the entities need. So as you know, in my game, every thing, like every character is an entity. So for example, enemies or NPCs or the astronaut or any creature, for example, everything is an entity. So so for that I have like a number of systems that are being shared by every entity. Hey Stakako, how you doing? Your stream layout color scheme remind me of my game. Oh really? Oh, now that you mentioned that, that's true. Yeah, that's true. The text adventure. What's the name? I don't remember, but yeah, the one you showed me in Bacon's Discord. That's actually true. So yeah, basically every entity has a state machine. Okay, and the thing is, what is a state machine? The placeholder name is Phoenix Protocol. Oh yeah, now I remember. That's the name that I remember from the GIF. I think you shared a GIF that we could see a couple screens. Yeah, that's nice. It's a great idea. I would like to see more. Amazing. So basically a state machine is just a system that the correct name is finite state machine, and that's because it has a finite a fixed number of states, and it can only be in one state at a time. So that's really useful for a number of things, not only characters, but one of the things that I'm using it for is for characters or entities in the case of my game. So, as you know, for example, the player character can only be in one state at a time, which is idle or running or jumping or falling or shooting. So all of those like are actually states, and the behavior, which is the state machine, is going to control that, is going to handle that. So now everything great to that point, but the more complex, like the more amount of states and layers of like actions or states that your character can do is going to increase the complexity of your state machine. Hey, the Ginger Dev, how you doing? I see you're still rocking on with the game. Yeah, of course. Yeah, actually, this game is going to take, I don't know, maybe 1 or 2 years for me to finish. Like, I actually want to get into, I don't know. I'm working towards some kind of demo to pitch, but yeah. I release Critical Role in a few weeks. Oh, that's great. That's amazing. It's really good. Let me know when you release it. I wanna check it out. Being able to jump and shoot at the same time, for instance. Yeah, exactly. So if you think about it, that's one state, because that would be, for example, if you want to name that state, it would be air shoot or air attack. So that's a different thing than the grounded attack. So each one of the actions that the player or any character can do is a state, essentially. So yeah, the behavior, the state machine is going to handle that. And the good thing about this is that the actual logic behind the state is going to run like each state is a class, essentially. So as you can see here, for example, astronaut idle, this is a state, and it is a class, and I have logic inside this state. So that's the really nice thing about using a state machine pattern and a state pattern, I would say, because you can like encapsulate the actual logic and everything that has to do with that state within that state class. Scary feeling, got Steam achievements and stuff sorted. Core gameplay loop is working on everything, already fully mapped out and plan my next game, creating an incremental game. Oh, that's a really that's really nice. You're kind of like getting to publish, like to actually publish your game, and you actually already have an idea for your next game. That's nuts. Oh, I love the component-based state machines. Fucking love building them that way. Yeah, I would say it's the most organized way of building them. It's like, of course, it depends on like the complexity of your game. If your game, like for example, your character has a couple of actions like running and jumping, you don't really need to build it this way. It's a little overkill, unless you just want the handiness of the editor, like having the components here and adding each state as a component. That's really handy and convenient, but for really simple character systems, you are just fine with like a switch statement, I would say. But yeah, it depends. What else? Oh, I see you're chatting about the game. Yeah, that's really great that you have Steam achievements also. That's really great. Yeah, the game cards. It's a good way of of making a little money. We don't make literally shit money, but it will be an amazing portfolio piece. Yeah, of course. My next game is an animal racing incremental game using the same animal models that I was using for Creating a Roll. That's kind of neat because it's like you can think about it as if they are in the same universe, for example. It's kind of neat. There's some people obsessed with having the badge from cards. Oh yeah, I'm one of those people. Nah, not like that, but for some games that I really like, I collect the cards, and then I don't know what's the thing, you kind of merge them and you like craft a badge out of the cards or something like that. Also, application intelligible. Can't do cards unless the game makes a certain amount of sales, I think. Huh. Ah, ineligible. That's what you're saying, yeah. I didn't know they had like, that kind of limitation. I guess it makes sense, yeah. Really funny because now that I think about it, I played Shinobi AOV and I 100% the game, and I also got all of the achievements. Like I had the platinum and everything on Steam. I don't have the console. So I played it and I basically completed everything that there is for the game. And I didn't get a single card from that game. I don't know. It was really... I don't know if it was just bad luck or I don't know. I don't know if the game has cards at all. I think it has because I remember seeing some people sharing their cards in the Shinobi Discord, but yeah, I don't know. Really, I guess it's just bad luck. I don't know. Someone mentioned it. Yeah. I think I saw that. In any case, I am not very interested in the Shinobi cards either way. It's like I really like the game. It's amazing. I like a lot of things about it. I get why some people are like not very like hyped about it. I get it, but I really liked it. Anything about cards is they have some high res art if you open them. Oh yeah, really? I didn't check that. Yeah, in any of the cards that I've owned, I never like actually entered into the card to see the actual art and everything. Oh, that's really nice. That's really nice. That's good. Would be great if you could download that to use it as a wallpaper or something. So yeah, basically, sorry if I changed the subject, but this is going to be a really short stream. So I basically try to I'm trying to explain the state machine thing while trying to explain the way I'm implementing this in my game. So yeah, basically this is what the entity behavior is. It's just a state machine that controls the state that you're in. Each state is a class that defines its own logic. So for example, the run state inside is going to control the velocity of the character. That's it. Then when you shoot, this state inside is going to have the logic for shooting and doing all of the things for actually like dealing damage and instantiating projectiles, for example, and that sort of thing. And that's basically like a really summarized version like of explanation of what the state machine is. So now where's the issue here? What's the thing that I was so stuck on? Oh, your message got censored. I think you can send the link, maybe like put in spaces in the link. I don't know how to turn off the link censoring thing, because it's really annoying, because it doesn't even let me like see the actual link and say, okay, I want the message to be censored or not. It doesn't let me choose anything. It's just it censors the link and that's it. So I don't know what option. Okay, I think there's yeah, there's a couple places where the censoring happened anyways. You can send it to the Bacon Discord and tag me. I think that should work too. But yeah, what's the thing that is like actually making me the thing that's hard for me to implement? So in the case of characters and state machines, there are a couple things that are like that. There are a couple things that have to do with the system and why you need them. So there are three main things. So this is basically states, transitions, and inputs. Okay. I would say maybe this would be like that. And I don't want this like that. Okay. So in a state machine, or in a character state machine, in this case, there are a couple things that make the state machine work, and those are the states, the inputs, and the transitions. So you need transitions to be defined for each state. And the thing that makes a state transition into another is an input. Okay, so in the case of the player, you can basically, oh, I see you already sent me the thing. Oh, I see. Wow, that's actually really interesting. Yeah, it downloaded the image basically. Let me see if I can open it. Yeah, whatever. Okay. This is the card image. Oh, okay. I was going to ask, is this from AOV? It's really weird. But no, now I get it. It's from the Sonic racing game. Okay, that makes sense now. Yeah, that's actually a really high res image, actually. It's really cool. And it's like you said, it's a lot more art than the what's shown in the card itself. Yeah, that's pretty neat. So we said in this system we have states, we have transitions between the states, and what defines the transitions is the inputs. So how does that work? When well, for example, imagine you're in the idle state with your character. So I can just go into the game and show you this. Okay. So when you're in the game, for example, like this, you have the idle state. Okay, this is already a state. The player is in the idle state, but then if you want to jump, I have to press the jump button to jump. So when I jump like that, the character transitions into the jump state. And the good thing the other nice thing about doing each state as its own class and using the state machine system is that you don't need to do a million checks for whenever you're doing an input. So it's pretty common for us developers when we're starting and we're making like coding a player controller to start like creating a really long if statement list, like nested if, because we need to be checking. For example, if I'm crouching, in this case I can't jump. I'm hitting the jump button, but I can't jump, and that's because I didn't define that you can jump from the crouch state. Same case, for example, when you attack. So when you attack, you can see if I'm grounded and I'm in the idle state, I can start shooting. And if I'm running, I can also start shooting. You can see here. Okay, but I can't shoot if I'm jumping. You can see I'm holding the shoot input, but it starts shooting when I'm land into the ground. So you can see there. So the good thing about states and state machines is that I don't need to be defining like a lot of ifs, like saying if is not jumping and also is not falling, but also if it's not crouching and if it's not, I don't need to do all of those like really bad checks, like a really long if statements to control the transitions between states, because the state machine system is what is going to handle the inputs from the player and then decide what transition is going to do. So each state is going to define which transitions it has, and then the state machine is going to read the inputs and say, okay, so we are in this state, and we are getting this input. So is this input going to transition for this state? Yes, okay, then we transition. If not, then we ignore the input. That's basically how it works. So it's a lot more clean and a lot more scalable. So the same example I was talking about, where if you don't want to be able to shoot while jumping, but also while crouching, and also while getting hurt, and also, so you can imagine how easily that can get into a really long if check. And the more actions and things you add, that's going to increase, and you have to be fixing a lot of things in the logic for that to work, for that new state to work. So yeah, that's why I'm using the state machine system for this game, and that's basically what almost every like game use for characters. Hey Lou, how you doing? Hello, welcome. Hello. So now there's a thing that is not easy about state, and that is, for example, I will show you right now. So remember that I show you so let me just here. So you see that I can shoot while I'm idle, but I can also shoot when I'm on the ground. So idle and run are two separate states. Okay, so of course, if I'm checking, like for example, let me show you the idle state. If you see here, I have this thing called check movement inputs. Okay, and this is basically I have these two methods that are going to be checking inputs to see if we are going to transition into another state or not. So, for example, in the case of the shoot animation or the shoot state, the attack state, from the idle state we can transition into the shoot state easily by just pressing the attack button, okay? But we can also go into the attack state while running. So what that means is the run state is going to have exactly the same logic. So that's another thing that's not great. Like, it's fine. It's completely fine. Like, in the sense of this works. I'm having to contact Steam support to get it changed from free to paid. Oh no. But why is that? Well, I guess they like, whenever you create a new game, I actually never published a game on Steam, so I have zero experience with that. I kind of know, like, more or less, like, how it works, but yeah, I never did it myself. So I guess they ask you like a couple of things whenever you're uploading the game and creating the game page, and you can't just change it. I would recommend you thinking about it prior to setting up the page. That was my own doing. Yeah, I can imagine. Yeah, it's a pretty big deal to change that thing on the fly, I would say, so it makes sense. So yeah, I am pretty sure, like, I am 100% sure that I will sell this game. So not the demo, of course, the demo will be free, but when I publish this game as a full game, it will be paid. But if you're making your game and are serious about releasing, set up a Steam page ahead of time. This way you can get wishlist super early. Oh yeah, of course, I do know about that. I do know about the wishlist thing and everything. It helps a lot, I know, but this game is so early in development that it makes no sense for me to create the Steam page. Like, I could create a page. I don't know if you can, like, unpublish a page or something like that. Not unpublish, but make it private. Like, if I, for example, create the page but maintain it private, it does make sense that it's for people on Twitch to back you, yeah. But yeah, in terms of like the actual game having an identity or like anything, because the game is nothing right now. It's like I have a lot of ideas and things, and I know what the game is and what I want it to be, and I'm building it, but as a game, like, I don't have anything, and I don't even have like screenshots. Like, this is the only thing that I built like by hand. It's like almost everything is placeholder, like, and I don't really have gameplay in my game right now. It's just prototyping all over the place. I'll be making a page for my new game the moment I start working on it. So if you create the Steam page, does that mean that Steam page is public for everyone? Because that's the thing. It's like, I don't want to create a Steam page, like an empty Steam page with like one screenshot and like a, I don't know, when I get to the point where I actually make the Steam page and everything, I want to make sure that I have something, at least some kind of ground with the game, like at least some kind of core gameplay going on and some screenshots, because like I said, the game has no content right now, no gameplay, no content. I'm purely working on systems and everything right now, so the only couple bits of gameplay that there is in the game is like really prototypey. Oh yeah. But Yeah, so as I was saying, basically this, I will, of course, as soon as I get to something that's showable on Steam, I will create the page and everything, of course. But for now, I think it's not worth it. I just want to keep like working on the game until I have something, some kind of gameplay going and some kind of content. Like I want to be able to show, oh yeah, so this is my game, and just start playing and kill enemies and go into a planet and do X and Y, and because otherwise this is just a character running around some random terrain generation thing. So it's yeah, it's really empty right now. But yeah, in any case, back to this thing. As you can see, as I was saying, basically I have the same checks and the same logic going on in both states, which, like I said, is not like the end of the world, of course, but it's not great to have so much repetition, because I know that, for example, in the crouch state, I also want to be able to attack, because I want to have a crouch attack, a crouch shooting animation. So for that, I would need to copy this and go into astronaut crouch and go here and do the same thing. So I think it's like in this case, I need like to organize the input check in a different way, and I think it shouldn't be happening in the states themselves. Like the actual states shouldn't be telling the machine, hey, transition to this or that. I think that should be handled like elsewhere. Because of this that I'm mentioning, because there are so many states that have transitions to like the same states in the same way. So so that's one of the things I was trying to think how I should make it and like what's the best way of doing it. So so yeah, I want to first explain what my idea is behind the entire like entity behavior and input and system. So usually this is how most games do it, or well, this is how it's done basically. So you have your state machine, okay, you have your state machine, you have your input reader, okay, you have your what else, your controller, and I think that's it. So in most cases you have this, and what this means is basically controller reads input reader reads inputs from player. Controller checks those inputs and makes the transitions between states. Don't clip the content. Okay, thank you. Okay, so controller checks those inputs and makes the transitions between states. Not makes, does. Okay, and then state machine handles. That's basically like that's basically how it works, how the systems are implemented generally for characters and everything. So you have your input reader, which is going to read the inputs from the player. Then you have your controller or something like that, which is another class that's going to read those inputs and from there it's going to say, okay, now like of course it's going to have, if it's going to check like some conditions. For example, the controller is going to check, hey, is the player grounded? Okay, so if the player is grounded, then it's going to check the inputs and transition to states based on those conditions. And then the state machine, like the controller is going to say, state machine, transition to this state. And the state machine, the only thing it's going to do is handle the current state. Like it's going to handle exiting the previous state if there is any previous state. Then it's going to set the new state and enter and run the enter logic for that state. So states have three like things that they do generally. So they have the enter and exit methods, which of course the enter method is run whenever we enter that state, and the exit method runs whenever we exit the state. And then we have the update method for the state, which is going to run every frame and is generally used for computing the logic of the state. So all of that is going to be handled by the state machine. Now, this is the traditional way of doing it, but the way that I thought about it when I started like a couple years ago working on this was like this. Okay, I didn't want to do that. So why is this yeah, I guess I should just make it really, really big. Okay, so you know what, I'm just going to move that outside and then just create the frame whenever I have everything explained. So what I thought about when I started creating all of these systems and implementing them was this. I wanted to be able to share the same systems across all of the characters, entities in the game. And as you can see, this would not quite work for enemies, because enemies like don't have inputs. Enemies just have like artificial intelligence that's going to decide on whether doing A or B or C. So for that, for enemies, usually what's used is behavior trees, which is basically a system that's going to have like nodes. They're called decision nodes. So basically, just an example, for example, you can say an enemy can patrol, and patrol is going to define, is going to decide if we idle or if we walk. Hey, Ragnaro, ¿cómo estás? ¿Qué tal? ¿Qué tal? ¿Cómo va? ¿Todo bien? ¿Cómo va el juego? Bien, bien. Estoy actualmente trabajando en State Machines. Un tópico medio complejo, pero bien, bien. La verdad que bien. Haciendo algunos avances. So yeah, basically the behavior, an example of a behavior tree thing is, for example, imagine that enemies can do, imagine just one enemy. That enemy can patrol or it can engage the player. So patrol is going to be is going to have two states. It can be in the idle state, or it can walk. Like it can walk from right to left, for example, in some place in the stage. Okay, so that's patrolling. The enemy is kind of patrolling. It can just be like idle, standing, or it can be walking around, waiting for the player. Then you have, for example, another decision node called engage. So whenever the enemy sees the player, is going to transition into the engage decision node, which is, in essence, it could be a state, but it's kind of a state that has substates because it's more of a strategy rather than a state. So when the enemy is in this engage decision node, that node is going to decide between, for example, running and chasing the player and attacking. Okay, so whenever the enemy sees the player, it's going to start doing something that the engage decision node is going to decide. So that's basically a behavior tree, and I'm going to be working on that in the future. But like, that's what's usually used for enemies and for enemy behavior and stuff like that. But in this game, I wanted to share the same, like those same components throughout every kind of entity. So this is how I thought about implementing. How can I just, okay, whatever. Just going to copy this again. So my idea was that every entity was going to have this, okay? And for example, when I talk about the player, okay, well, I can do it here, I think. So if I want to share this, I was thinking, how can I share this across all entities and have like player and enemies and NPCs use the same systems without having to implement behavior trees. Of course, at that moment, I didn't know that much about behavior trees and everything, so I was basically just creating everything from the resources and the tools I had in my mind. So what I thought was basically, okay, so every entity can have a state machine, every entity can have an input reader, and every entity can have a controller, okay? So in the case of enemies, yeah, I'm going to do it here. So in the case of the player, the input is going to be for example, controller, keyboard, joystick, etc. Okay, I will use a comma because it's going to be much cleaner to read. Okay, so in the case of the player, the input for the player is going to be the player itself, like whatever inputs the player is doing. So in the controller, like pressing inputs in the controller, or on the keyboard, on the joystick, whatever thing they're using to play the game. So then those inputs are going to be read by the controller and the transitions and everything. But what happens in the case of the other entities that are not controlled by the player? So that would be NPCs, enemies, in the case of that, what's the input? Well, the input is basically AI, okay? And what does that mean? That means that instead of the enemies having a behavior tree that defines decisions and strategies that have like a defined set of states to go to, okay? So for example, instead of having strategies, instead of having strategies to decide the current state, which is, again, this is a cleaner way of doing it. Like, not a cleaner way, it's just another way of doing this. And I'm trying to think about what are the advantages of each way of implementation. Instead of having strategies to decide the current state, we have a virtual brain AI input that's going to decide what input to do based on okay, so this was my original idea with how like any entity that's not player controlled was going to behave. And I'm trying to like I'm not I haven't decided yet if I'm going to stick to this or implement behavior trees. And I think there's a possibility that I can combine this with behavior trees. So basically what happens is, in this case, for example, in the case of the enemy, the state machine is the same, the controller, but like the state machine is the same system is going to be shared by the entity, but in the case of the input reader and the controller, those would be merged into one thing that would be called a virtual brain. That's the name I gave it at the time, because it's in essence is kind of like a virtual brain that's going to decide, like for example, it's going to say, okay, so is the player inside or not? Is the player not inside? Do I have any enemy like in my sight? No. Okay, so then I'm just going to be patrolling and I'm going to press the input for walking for a little bit and then whatever. So and then, for example, if the player is in sight, then instead of saying go to this state, the system will actually like press the inputs like forward and jump, or for example, or forward and attack to do the actual actions, to transition into those states. Now, this is a neat idea, because what this means is that since the virtual brain is a class that inherits from the base class called input, that means that every entity can share like exactly the same systems, like the state machine and the controller and everything, because everything would be implemented and created from the same base thing. So everything would check for the same things, okay? And what that means is, if I want to, I can give an enemy, instead of giving an enemy a virtual brain, I can give it a player input, and you would be able to control the enemy, okay? And you will be able to control and do the things that the enemy can do. For example, if the enemy can run, jump, and do one attack, then you could do that, like control, like run with the D-pad or the directional input. Then you could jump with the jump button and attack with the attack button. Of course, you wouldn't be able to do anything else because that enemy just has that set of actions. But for me, that was kind of a neat idea. And now the only thing is that I never thought of that as well, I did at some point think of that as an actual mechanic on the game, where you could do something to actually control an enemy or any other entity, so you could control it and do stuff with other entities in the game. Like for example, you could just, like, I don't know, thinking about a really dumb example or easy example. Imagine you have some kind of item, like I don't know, like a sphere or something, an orb that you can throw into an enemy, and if you hit that enemy with that, then you possess that enemy and start controlling the enemy. That would be easily doable by just implementing the behavior state system this way. Now, what's the problem with this? Actually, I think the only issue with this is that, for example, the input, which is actually not an issue in terms of implementation, but what I currently have implemented. So if I decide to keep this, I will need to extend and keep improving the classes that I already implemented. But right now, input class has like a limited amount of inputs and actions defined. So, for example, let me go into the input controller thing. And I was doing some refactoring on this, like while I was off stream this weekend. I was doing some refactorization of the input controller class because it was a really bad mess, and it's kind of still is, but whatever. It's a lot cleaner now and needs some more work, but that would be for another time. So you can see here I have action type, and you can see I have start, jump, attack, and interact. So start is your typical like start button in the controller. Then you have the jump action. Like those actions are not bound to buttons, they are just actions. But this one I called it start because it's like the typical start button, like the menu button, if you will. But then you have the jump, attack, interact. The idea is that they are not bound to actual buttons in the layout of your controller. You can modify the inputs whatever you want. You can rebind the inputs. That's what I'm trying to say. But I have a set amount of actions that you can do. And this is shared across all of the entities. Now, the thing is, imagine we have some kind of enemy that has, I don't know, I'm just going to give like a really exaggerated example. Imagine an enemy that has 10 different attacks. Now, the player only has one attack. And that's my idea. You as the player will only have one attack input. That's my idea. Then you can change the thing that you do when you attack. You can shoot. You will have different types of attacks, of course, but you will only have one attack input. Now, what happens with enemies that have like multiple attacks? Well, they are going to press the attack input, but they are going to decide what attack to do based on some context or conditions. So what happens when you start possessing that enemy and you try to do an attack? If you only have one attack input, what's the attack that's going to come out? Is it attack 1? Is it attack number 7? Is it attack number 4? So that's one of the things that that's something that I would need to define if I go on with this kind of implementation, which again, I didn't think about this as an actual mechanic to be able to control enemies or NPCs or anything. Like I kind of had some idea that I'm not really convinced about it, but a couple of years ago I thought about that could be interesting to be able to control other entities like creatures, for example, that fly. You could fly around, or enemies that jump really high. It would be interesting, of course, but I don't really know. I would like to explore that, but like for that to work, I would need to implement it this way, the way that I'm actually implementing, like the way that I have been implementing it until now. So basically now, like I kind of need to make a decision if I continue with this implementation, which I'm kind of like, I would say, 60% more inclined toward this implementation, because I think it actually sounds fun. Because what I have been thinking is that instead of the virtual brain actually pressing inputs, I will have like another layer that would be a behavior tree that would then decide the input based on strategy. Okay. So that would be that's the thing I'm trying to think if it could work, for example. So I would have a behavior tree that would decide the strategy, and then the strategy would choose what input to press. Instead of saying, instead of the strategy saying, okay, go to this state, it would press the input to go into that state. That's what I'm trying to say. And in essence, that would be kind of the same thing that I'm doing with the player in the controller system, which checks which input is being pressed and doing something like transitioning to a state based on the context and some conditions. Okay, so yeah, that's kind of what I'm trying to get to with this. It's not easy. I'm going to make this smaller so that I can, well, this should also be smaller. And yeah, I don't know. I will try to implement it this way, and I will try to think about how I can make this work. Because I think it's a really neat idea. Even if this is just for debugging stuff, I don't know. I would like to think about it and just try to implement it and see how far I can get. Of course, like ideally, I don't want to spend time like working on something that I will then like scrap entirely and just have to work again from scratch on a system. That's never fun. But in this case, like, of course, I don't have a deadline for this game, and I can just work on this for as long as I want. Of course, I want to eventually like finish a demo at least and pitch it and see if I can get some funding for the game. And I would love to actually be able to work on this game as my main job. Like that would be my dream, of course, but it's really hard. So I'm not like fixating on that too much because it's not easy, of course. But we'll see what happens. So yeah, that's gonna be the stream for today. Okay, I need to go now. I need to do some stuff, so that's why the stream was going to be a bit shorter than usual. But yeah, I think I'm mostly sure that I will be back on Wednesday, as always. My schedule: Monday, Wednesday, Friday, and Saturday. We'll see if I can get to do all of those streams this week. But anyways, in the next stream, I will try to give it this a shot. I will try to structure the systems and see if I can make it work for the player and for any entity. And we'll try to make it as modular as possible and see if it makes sense, or if it's like a pain to work on. Well, in that case, I will just scrap the idea and just start over with another strategy. Okay, but yeah, so that's going to be the stream, and thank you, Sakako, thank you very much, and the same for you, Have a good rest of your day. And yeah, oh yeah, of course, don't forget to join the Discord if you want to get notified when I go live. That's a good way of knowing that. And also you can share stuff there if you're working on a game, if you're whatever thing you're doing, if you're doing art, you can share there your stuff and you can get some feedback if you want to. So yeah, I think it's a good idea if you want to join. And yeah, so also if you're watching from Twitch or from YouTube or from whatever your place, or if you're watching the VOD, consider following me on Twitch and subscribing to the YouTube channel, where I basically archive every stream that I do, so you can go and watch every stream there. It's going to be archived forever there. That's great. So yeah, again, that's going to be the stream for today. Okay, thank you very much for watching and for chatting and for everything, and I will see you in the next one. Okay, bye bye.